Assalamualaikum and greetings to my panel. I am Mohamad Fathullah bin Mohamad Harani from 4 BMFG 2/1 and my matrix number is B0518100094. Today I would like to present my bachelor degree project 2. The title of my project is Design Improvement and Vibration Analysis of a Fabricated Pipe Bevelling Jig for Welding Preparation. My supervisor is Professor Madya Dr. Izan Syariah binti Hussein. First, I would like to present the introduction. For the background of study, the pipe beveling angle preparation must be in a range between 30 degrees to 45 degrees and it will form 60 degree to 90 degree angle for both ends of pipes. Next is by using a manual hand grinder, the probability of achieving an accurate dimension would be low due to the inconsistent method of grinding and the vibration from the grinder itself. For the vibration effect of the worker, manual grinding might affect the worker to have a vibration white finger VWF condition due to prolonged use of vibrating hand tools. According to Shizin and House in their article, hand-arm vibration syndrome is a common occupational issue that impacts employees in many sectors that utilize vibrating instruments. Next is the problem statement. Prasad and Lingraju in 2017 stated that the pipe beveling requirements tolerance must be followed to get a perfect weld. Fatak et al. In 2021, only skilled worker can bevel a pipe manually using a hand grinder. When a bevel angle is accurate, a high depth penetration will be achieved. Vibration white finger disease could affect the worker. It is a long-term effect on the worker that results from prolonged use of vibrating hand tools such as grinding machines. By Kultul and Tuk in 2018, there are three objectives need to be achieved in this project, which are to analyze the vibration and angle accuracy of the fabricated beveling jig for welding preparation. Second, to perform design improvement of the fabricated beveling jig for welding preparation. Last, to validate the improved design of the beveling jig for welding preparation. While the scope is focused on the design improvement of the fabricated jig and vibration instrument and bevel angle accuracy produced by the jig. Next is methodology. The workflow of the study is presented in a flow chart. It starts with preliminary testing, measures the vibration and bevel angle accuracy. Next is the design improvement phase. The problem will be defined and possible solution will be proposed based on the existing fabricated jig. Then it will further to material selection process to determine the best material for the design improvement part. The concept design will be implemented by using a morphological chart, screening and scoring. After the concept design was chosen, it will undergo fabrication for the design improvement part. The design improvement of the fabricated jig will undergo experimental to validate the improved design of the beveling jig for welding preparation. All the readings and measurements are taken into account to provide the discount and analysis. A conclusion will be made after all the process are done. Description of fabricated jig is by using the fabricated a constant degree of bevel angle can be achieved rather than manual grinding operation. It can produce 0 degree until 70 degree. This jig also can reduce the worker's vibration exposure when using a grinding machine to prepare a pipe bevel, but workers are still exposed to vibration when the workers need to roll the pipe. While for the limitation is pipe length must be less than 304.8 mm and 1 foot, or the diameter must not exceed 3 inches. Further design improvement can be obtained to eliminate the exposure to vibration. Preliminary testing has been conducted to measure the magnitude of vibration for the existing jig by using a vibrometer, hand-arm vibration meter. 3 readings were taken to get the average value, then the bevel accuracy was measured using a bevel protector. 3 readings are taken to get the average value and standard uncertainty. Next is the design improvement method. Firstly, we need to define the problem of the existing fabricated jig to avoid hand exposure while using the jig. A motor with a 3-jaw chuck has been proposed to rotate the pipe automatically. A vibration padding has been suggested to reduce the vibration and will be installed under the bed structure. When stress from vibration is applied to the rubber materials, the rubber padding absorbs greater vibratory stress before breaking or transferring the vibration. For the design improvement for the fabricated jig, it started with a morphological chart. Various application design and concept were proposed to consider the best design and the dimension for design improvement of the fabricated jig. Different mechanisms to rotate the pipes were also being proposed to ensure that no vibration will be exposed to the worker while using this jig. Several motor placements were also being proposed to consider the proper placement of the motor. Next is concept evaluation. The combination of options stated in the morphological chart creates the three most suitable concept designs. Then it goes through the screening and scoring method. Through scoring method, the concept design with the lowest score will be eliminated. Concept design A and B will go through the next phase, which is the scoring method to select the best design among all design concepts. The concept design uses a 3-jaw chuck to clamp the pipe. The motor was placed at the end of the jig and it can be moved toward the pipe to secure it. Then it is a direct mechanism where a 3-jaw chuck was attached to the motor. The motor height will be adjusted by using the lifting base where it can meet the center of the pipe. Lastly, the pipe clamp has moved near the grinder to avoid misalignment when the pipe starts to rotate. So the base lifting base of the motor have undergone the cutting, joining and drilling process. Then a drilling process is needed to drill a hole at the bottom part. All the parts are joined together by a joining process. Anti-vibration padding will be installed under the base structure and the pad will be cut according to the exact dimension of the base structure. This improvement will cause the reduction of vibration occurring from the grinder and the motor attached to the jig. The base structure will be extended and it involves steel plates and the linear rail to be extended to place the motor mount and lifting base. Since there is no exposure of vibration occurring during beveling by using the improved design jig, the vibration magnitude is no longer needed to be measured. The bevel angle accuracy will be measured 3 times, then the measurement will be compared before and after design improvement has been implemented. Next is for the result and discussion. The highest vibration magnitudes occur during the beveling of 3.5-inch pipe, which is 116.59 meter per second square within 5 minutes and 43 seconds. Referring to the ISO European Standards vibration exposure table, this exposure is within the yellow indicator, which means that the levels are approaching the exposure limits. When certain levels have been reached, the employer must take steps to limit daily exposure. Therefore, improving the design of the jig is an initial approach to reducing or eliminating the vibration exposure for the worker while beveling a pipe. From the result of the bevel angle accuracy, the average value of the uncertainty was 0 degree 34 minutes 41.5 seconds, which indicates the beveling jig was able to produce a constant degree of bevel angle. This is because the jig and fixture facilitate finding and fastening the pipes and assuring the proper location of the grinder concerning the pipe. The design improvement of the fabricated jig will be generated after the possible solution for every problem has been identified. From the previous design, the design still requires a worker to rotate the pipe to produce the bevel, which exposes the worker to a vibration while beveling a pipe. An automated pipe rotator and 3-jaw chuck have been proposed and fabricated to solve those problems. This design improvement has significantly helped to eliminate the worker's vibration exposure. The extended base structure was fabricated by using a laser cutting machine and the linear rail has been attached by using a bolting mechanism. For the motor, with a lifting base, it was drilled by using a milling machine. It has been attached by using a bolt and nut, while the 3-jaw chuck was mounted by using a motor shaft adapter. Lastly, the vibration pad was installed under the base structure by using a heavy-duty adhesive tape. The improved design of the fabricated jig was able to achieve accuracy for the bevel angle measurement. According to Hubashar and Paul, 2003, the bevel angle varies from 70 degree to 90 degree. Therefore, each pipe must be less than 45 degree and more than 35 degree bevel angle. The standard uncertainty shows the result of accuracy of the bevel angle before design improvement indicates 0 degree 34 minutes 41.15 seconds, while the value after design improvement was slightly lower, which is 0 degree 23 minutes 55.98 seconds. The accuracy and precise measurement of bevel angle can be achieved due to the constant speed rotation of the motor to rotate the pipes in producing a constant degree of bevel angle. So in conclusion, The vibration and the angle accuracy of the previous design of the fabricated jig has been analyzed, where the bevel angle produced by the jig and fixture was more precise rather than bevel using a grinder manually. The design improvement of the fabricated beveling jig has been implemented after the problems have been identified from the vibration analysis. The improved design of the beveling jig for welding preparation has been validated through bevel angle accuracy analysis by calculating the average value degree of uncertainty. For the recommendation, the product should be fabricated using a high precision machine to reduce reworking and waste or scrapping of components that are not quite up to standard. Next is the design of a better mechanism to rotate a pipe to produce a bevel angle for various sizes and lengths of pipe. So that's all from me. Thank you.